Hello everyone, I'm Kang. I'm from Instagram client performance team. So today I'm going to tell a story about how we scaled up the code base in the past 4 to 5 years, and how do we meet our product requirements while achieve our performance and reliability goals. Before I get into the detail about the talk, I would like to mention that our team is a team based in New York because New York has a lot of mobile talents. We relocated from Silicon Valley to New York this year, and we have a lot of great challenging projects going on. And especially we have a lot of teammates and coworkers from Facebook, Instagram in this room at the back like today. So if you get any specific question about how anything is implemented in Instagram or Facebook, feel free to reach out at the end of the talk. And also if you are interested in working with us, please reach out to us. Okay, let's get started. So a little bit about myself. So I joined Facebook 4.5 years ago. I worked on various Facebook Android products. I worked on Facebook for Android, Facebook Messenger for Android. I joined Instagram about roughly 3 years ago, and I have been working on the app ever since then. The team was 4 to 5-ish people when I joined, and it's now we have 30-ish people working on the code base. I was very lucky to witness the code base scaled from a relative mid to small size code base to a code base that supports 30 engineers working on it, constantly delivering new features. So today's talk will be mostly in 3 parts. The first part, we will talk a little bit of history about our product and our code base. Then we will talk about some unique challenges we saw in today's Android development. Then we will introduce some practices and exercises we have been doing internally in Instagram to overcome those challenges. And hopefully it will be useful to you and your project as well. So a little bit about our product itself. Before we get into it, I'm wondering how many of you guys have been using Instagram. Could you raise your hand? Cool, that's a lot of people. So for people who didn't raise their hand, or for people who didn't know what Instagram is, Instagram is a social network where you can share photos and videos to your friends and families. So it has been a really successful product. The product was first released on iOS in 2010, 2011, and the Android version was the first time released in 2012. And it might be one of the most anticipated Android app on history. We got more than 1 million downloads on the first day. So right now we have more than 500 million users on Android and iOS. I'm happy to report that last month we hit a new milestone where we got more than 1 billion downloads on Play Store, which is huge for us. I think quality and performance has really been the core of our app, and that's the reason why we maintained the 4.5 star rating on Play Store ever since day one. Users love the app, and we have been, every engineer who work on the product are very proud of it as well. So a little bit about the code base itself. So our code base is 5 years old. It's a small kit. It's mostly Java. We have 90%, 95% code in Java. We have C++ code to facilitate certain CPU-intensive job like image processing, but it's mostly Java, and we love using Java. The scale of the code base increased from 2 engineers working on a product to 30 engineers today. And because we have more and more people working on the code base, the number of commits in the repo grow in an exponential fashion. And here's a graph I just crawled before I came here today. It shows you the number of commits in our repo, how it grew over these years. You can see it's growing in an exponential fashion. And I also want to mention that as an Instagram Android team, we do not only maintain the Instagram Android app, we actually have multiple apps on the App Store. Right now in the United States, we have Layouts, Boomerang, and Instagram on the market. And the thing I want to point out here about Codebase is that those small apps, they share a lot of code from our big Instagram mother app, and it shares For layouts, it shares more than 55%, and for boomerang, it shares more than 60%. I see this this as a sign of like a healthy code base because we were able to share a lot of code between those apps. I will get more into the detail about how we accomplish that later. The last thing it's worth to call out is about the performance of our app. We always think about building software as building a car. You can think about maybe you want to build a RV which has a lot of features, or you want to build a bus which can load a lot of stuff. But we at Instagram, we always think about building a race car. It needs to be fast, it needs to be enjoyable. And that's why we care performance a lot. So we are one of the fastest app according, in terms of code star, according to third-party benchmark they did last year. I mean, Nimble Droid did it. We were one of the fastest among top downloads apps in Play Store. And we are also a single DEX app. I'm not sure how many people here understand, how many people understand very deep about how Dalvik works. So Android has this limit where you cannot have more than 65,000 methods inside one DEX file. And if you ever overflow that limit, you will have to pay extra code star overhead. That will slow down your app, and it will slow down method calls as well. So we have been trying very hard to not push through that limit. And we are very proud that we are a very small app, and we are very compact and fast. And the APK most people download today is relatively, it's not smaller than 4 to 5 years ago. That's impossible, but the size is still comparable. Like the first version we released in 2012 was 13 megabytes, and today's the APK most people download is 16, 17-ish megabytes. I see it being very, so we manage the scale of the code base and the size of the app like very successful in these years. The next thing I want to talk about is the challenges in today's mobile, especially Android development. Android has been growing rapidly in recent years. In last year, I think there are more than 1 billion smartphones shipped on this planet, and more than 80% of them are Android devices. And you can see this data from IDC, which proves that as well. So with that huge market, it's a huge opportunity for every Android developer, because if you can make a successful app, you have the potential to reach hundreds of millions of users. But it also means challenges. The first challenge is device fragmentation. Because Android runs on different devices, it's an open ecosystem. Some devices might have 1 core, some devices might have 5 cores. They can run different OS versions ranging from Froyo, Gingerbread, all the way to Lollipop and above. You also have devices have different like DPIs, screen density. So all those combinations, as a developer, we have to factor them in to our consideration. And also, because Android has a large user base on this planet, those more than 1 billion Android users, and they are in different places in this world. And they have different network connectivity. The network speed could be fast, could be slow, and you have to consider that as well. The third challenge and the fourth challenge, they are actually highly relevant to each other. One is if you think about the old days, how people develop client-side software, like Microsoft Windows or Offices, those software tends to deliver a new version every year. And you do like 6 months to a year maintenance on the software, and you get a year of time to like do planning and big refactoring. That gives you like enough headroom to do a lot of big changes. Versus today for mobile development, because how intense the competition is in the product on the product itself, you rarely get a lot of time to do big refactoring. So under this circumstance, how do you make sure the code base is still maintainable in long run, especially for instance, for us, we have been maintaining this code base for like 5 years. How do you maintain a code base for 5 years and make sure new engineers can still ramp up quickly while like large changes can still be pushed through the whole product successfully. Well, honestly, I don't think we find the best answer for all those challenges yet. But today is more about like sharing our stories and practices, like how we tried to overcome those issues. So we categorize challenges into majorly 3 aspects. The first aspect is the quality of your app. Is your quality doing the job where you advise, where you promise to the user? Is it crashing a lot? Is it using a lot of battery? The second category is the performance, which is the thing you actually want to be good at, the thing you want to be better than your competitors. Can you upload a photo faster than your competitor? Can you display something? Can your scrolling performance be much smoother than your competitor? The third part is about third aspect is about code base health. As we discussed before, the code base needs to be maintained in a really long period. So making sure the code base is sustainable is very important, and it will pay a lot of dividend in periods like 2 aspects. So the first practice I like to mention here is our, it's kind of like related to today's talk's title. It's called Lean App Architecture. So we have been trying really hard to make sure the app is compact, the app is fast. That actually requires a non-trivial amount of work. For instance, for external dependencies, we have dependency tests where we can ensure our every external dependencies is listed in a whitelist. And from the whitelist, you can trace back to when and where, for what reason external dependencies is added to your app, so that you can audit the dependency and every time when a new dependency is added, and like making sure a new dependency is only added when you really need a large portion of it. So we think about dependencies as something, we take like importing a library is, I mean, today's toolchain makes the importing library like too easy. That's like my opinion. Like you always like can import one line and that will screw up your project because it has like too many methods. So you need to be really cautious about all those and making sure you import a library and use all of them. And we have like real-time dashboard to track the method count in our app, and we periodically look back what happened in past weeks, months. We annotate all those changes and try to figure out the long-term trajectory for our app's growth. For instance, the graph I show here, which is a recent exercise we did with our method count dashboard, where we annotated out all the libraries got added to the app, all the libraries that we successfully removed from the app. And from there, we were trying to analyze and see what the trajectory look like and what mitigation strategy we should use. It's better if you do this exercise before your app actually passes the threshold. The reason we are able to keep the app under single DEX is because we have been doing this exercise for like years. Like we started doing this in 2013. Another aspect of a lean app architecture is besides the external dependencies used, we also care the internal structure of the app. So you really want to make sure as we said before, like we think about ourselves as building race cars. As a race car, you want every component to be super efficient and customized. You want to be able to optimize everything end to end. So we own every major infrastructure in our code base. For instance, our image cache, which only has 10 files, this is what I counted it yesterday before I came here, including interfaces and data models. It's super efficient, it's super compact, and it's highly customized. It supports all the features we need, even including progressive JPEG and blur images. But the most important part is the performance of it is really good. So if anytime you have used the app, I think you might have noticed that like our app might really show any placeholder if you have ever downloaded the image already, like unlike any other app on the market. You scroll back and forth, you see those beautiful images, and it's very challenging because the image we display in our app is actually very high fidelity. Those images are usually 1080p by 1080p. So it's a lot of pixels. So being able to cache them and display them efficiently, reduce the chance people see placeholder, really make us successful. And that's part of the lean app architecture. You really want to own the core part of your app and optimize it to the point where you cannot improve anything. The other part about lean infrastructure is that you want to adapt. And there are a lot of new patterns and new things being introduced to software engineering, especially to Android development. Being cautious about new concept and always take one step back to see if you have the problem the framework was trying to solve. And make sure you understand all your problem and try to find a solution for it instead of just find a very fancy new library and import it to your project and call it a day. So we have been very cautious about any new technology. We have been trying pretty hard to keep everything as close as to vanilla Android. Our code base, the product code look very similar to vanilla Android, and we have a lot of internal, like very efficient infrastructure, but even for those infrastructures, we make sure the API is coherent with Android APIs so that new people who join the team can ramp up really quickly. For the same reason, we haven't started using dependency injection yet. Again, it really depends on your skill and the problem you are trying to solve. Maybe in future we will revisit it, but it has been working really well for us until now. The second point I want to mention is that being pragmatic about all the problems you are trying to solve. We call it optimize what matters. The story I want to share here is about JSON parsing. So when Philip and Shane developed the first version of the app in 2013, and when they tested it internally, they found that the Explore page of the Instagram app took more than 20 seconds to load on a few devices. And the reason behind that was the JSON parsing for that page was just too slow. The reason it's too slow is because Dalvik is very slow on reflections and allocations. So I'm not sure if anyone is familiar with modern JSON parsing framework, but most of them does this two-phase parsing. It will first parse the JSON token stream into an intermediate dictionary table, and then it will map that nested dictionary into the final model class. And this process involves a lot of reflections to look up the model class. It involves a lot of allocations on the intermediate data object, the dictionary object. So the solution to this perfect problem is that you want to do streaming parsing. So you basically want to parse your JSON token stream into the model class directly without any intermediate allocation. And you also want to avoid any reflection calls to look up the annotation on the model class. So the typical JSON parsing code would look like something on the left, where you use the object mapper, read a value from the JSON parser, and load it as a class. The streaming parser code would look slightly different. It will be something more like a huge while loop where you just iterate through all the possibilities for this token and try to find out the proper field for it in the model class. So this avoids the reflection, this avoids the allocation, and it works really well. It significantly reduced the parsing time. The parsing time for that Explore page on a Frio device was reduced from something around 20 seconds to like well under 1 second. So again, like you want to optimize what matters. You need to first build the app and see what's actually slow instead of trying to guess what could be slow and do a lot of premature optimizations. The second thing I want to mention here is like about simplicity. So Instagram, the app itself, values simplicity a lot. We don't have tons of features. compared to any other apps, like the feature Instagram carry is like pretty minimum. And on the engineering side, it's also reflected in our day-to-day work, where we would prefer to do simple things first. We would like to keep our approach simple. Continue the example we talked about previously about JSON parsing. So after we realized there is this technique to make things faster, but there was no framework, or there was no tool actually support this. There was no tool chain that could do this streaming JSON parsing back to like 2012, 2011. So what would you do? Well, like what we did was very simple. We just wrote the parsing code by hand. It's a huge while loop, and we wrote the while loop. And it worked out really, really well. The reason behind that is the team was really small. It's 2 to 5-ish people. And this JSON parsing code is actually something that can be unit tested very easily. So every time you write a new JSON parser, you just write a JSON parser test, and it scaled out pretty well. Until 2014, we had like enough engineers on the team where we constantly hit issues in those parsing code because new people might not know all the pitfalls in like handwriting those JSON parsing code. And we started investigating how to do these things better, how to reduce like all the human work here. So we decided to do this annotation processor, which is called JSON parser. If you are interested, you can find it on GitHub as well. So it's basically an annotation processor. It looks through all the annotations you put on the model class, and it will generate this streaming JSON parsing function for you. So again, do the simple thing first. So if you look back at the story, like we didn't invent this thing until we really have this problem with the scale of our team. The next thing I want to talk about is about the fail fast philosophy. This is, to my opinion, this is kind of like the part where we keep our apps quality very good in the market. So the fail fast philosophy means you always want to detect the error as early as possible. So if you think about how we detect errors in our product, you can detect it through, I guess, like low star rating in your Play Store, or like you can detect it through like user report. You can also detect it from the crash report, or you can make the compiler to fail to compile if something is not hooked up correctly. So we prefer to move these detections as early as possible in our development process. So if something that can be detected through the language safety feature, we would rather do that instead of turning it into a runtime crash. If something can be detected through runtime crash, you would not swallow the exception and swallow the bad input and turn it into a bad user report. Because those vague user reports are usually really hard to debug. So the example I want to share here is how do we share controller logics inside our app. So if you're familiar with Instagram app, our app has a lot to do with photos. And we share a lot of view rendering logic inside of our app. So on every tab, you pretty much can find a way to go to like a full like photo view. And that means that a lot of rendering logic needs to be shared across different screens, across different controllers. And in order to do that in a strongly typed fashion, we have been doing something called delegated pattern. It's very similar to the iOS response chain pattern, where from the example here, you can see that when we bind a model class to a view, we also provide a delegated class where we can dispatch the callback. For instance, here, like we bind a media object to a media view, and whenever this media view is clicked, we want to dispatch the callback to something. And here we have a delegated class for it. And the thing worth noting here is that the delegated class is strongly typed, and the on media click is strongly typed. The media object we pass back is strongly typed. So if you think about the structure of our app is like like your view controller class is should always look like a tree. So like it's small controllers, and the small controllers will compose the big controllers. And because of this delegated pattern, we will for those big controller which is composed by small controllers, they will have to implement the delegated interface defined by small controllers. So this actually enforces that if you want to reuse this controller in different screen, you will have to implement the interface that delegate defines. And that delegate defines a strongly typed interface, and it has all the possible callbacks for this controller. Therefore, like if you reuse the same controller in different screens, you will, if you miss a callback, the compiler would not even let the code to compile, and you will get a compiler error for it. That's what we call fail fast. And as a result, the code base has been pretty easy for new people to, for new engineers to pick up and ramp up. We rarely have any product breakages because of unintentional changes. Another part about keeping a good quality is to detect the error as quickly as possible. That means you need a very fast and agile release process. For internal developers, we have continuous integration, so we build a new build every diff. And for employee dog fooders, we push a new build every 4 hours. And we have a beta release every other day. We have a public release every week. That gives you a very fast iteration cycle. And we also have real-time crash monitoring, where you can compare the crash between different versions, and you can clearly see where the regression is coming from. So again, like it's this fast and agile release process is also related to fail fast philosophy. You really want to detect the error as quickly as possible so that you can act on it like quickly. The last part I want to talk about is about code base health. I think some best practice we have here is that the first thing is you want to constantly refactor your code base because always the product itself keeps changing, and the product requirements from last year might be very different from the product requirement today, and there might be a lot of legacy code which was designed to support these old features which was deprecated already. And even if you even if you are working on a product that's not like updating a lot, you still, just because you can still like do the abstraction every time when you do it, you can still do it better. So we constantly refactor our code base and try to find out where we can improve in terms of like making the API more strongly typed, like make the API more safe in terms of making it faster. And I guess the main point here is like you want to minimize the legacy code because it really slows you down. And as a result, we have a lot of libraries that we developed internally, which is it's a mini app toolkit, and it's highly modularized, it's pluggable. You can just choose compose them together and to build a new app. And that's how we accomplish the really high code reusage between different apps, because all those modules, they are like shareable, and you can easily reuse them in the new app. And because they are developed and tested in the main app, all bugs and performance issues will get fixed very quickly as well. The next point is about developer experience. It's not something that's very intuitive, like how it's related to code-based health, but it really helps because a very short feedback cycle can actually allow people to do more changes to the code base. It allows you to clean up the code base easily. It allows you to, even if you just make a simple change, being able to compile it and test it in different flows would give you more confidence and allows you to move faster. So we have been maintaining like sub 10 seconds incremental build time, I think ever since 2012, 2013, and it's a pretty enjoyable code base to work on. And it also helps new people to ramp up on the team because they can just like make some change and see, okay, like what what component did my change affect. The last part is about mentorship. So as a team as team is growing, you really need to pass all the knowledges and history to new people who is in the team. It's the history and the context about all those decisions are usually more important than the decision itself. That's the reason why, on average, our engineers spend at least 20 to 40% of their time on code reviews, mentorships, pass on all the knowledges to new people. Cool. So to summarize what we have discussed today, I mean, if anything, I wish everyone could remember is don't try to remember anything from the previous talk because different apps are different teams are different. There's no one-size-fits-all solution. You really want to pick up the solution based on your product, based on your skill, and at the end of the day, what you deliver to the user matters most, and whether your product is successful matters most. So also keep learning and keep revisiting your assumptions about different technologies. That's pretty much it. That's my email. Thanks for everyone here. If you got any questions, you can ask, or you can ask anyone.
Talked a lot about keeping the app simple and only bringing in libraries to solve problems that you have been facing. So can you name an example of a time that you faced a problem so large that you're like, okay, we'll bring in a different library and actually bring that in as part of the Instagram code base?
Yeah, we did so it's a constant exercise you have to do every time when you import a library. I can share two examples. One example is Guava, which is a bad example where we imported the library first. We thought it's going to be useful, it's going to be awesome. And it turns out the only thing we need from it is pretty much the precondition class. And anything else is just a lot of burden added to the DEX file. And we decided, okay, look, we don't need everything from Guava. Let's just keep it simple. Let's just use one class. So we took 1 week to refactor the code base to get rid of the Guava from our project. It was a painful process, but at the end, it allowed us to move faster in long run. Positive example would be, I'm not sure if you guys are using this, but there is this awesome animation library Facebook wrote called Rebound, where it actually allows you to do state-based animation. So we have a lot of new animation, cool animation in our app, in layout, is actually powered by this framework. This is one example where you see something that the default Android toolchain is not doing a good job on, and you want to bring some new library to facilitate it. But again, we looked at the library closely. We assured that there is no nothing that we don't need from the library before we actually imported it. Cool. Thank you. Hey.
You said you don't use dependency injection. Are you saying you don't use dependency injection frameworks, or you don't use the pattern?
Frameworks. I think pattern. Yeah, that's a really good question. So framework-wise, we looked into a bunch of frameworks, and back to that time, last time when we did the exercise, I think it was 2013. There was no good DI framework which was mobile friendly, I would say. Most DI framework has a very big old head on CodeStar, and we just didn't feel we needed to use any of those to accomplish what we had in the app. And in terms of the DI pattern, yeah, we do use DI similar pattern in many places in the code base, just because we want the code base to be highly modularized so that you can compose them together as a whole, but you can still, the reason we have sub 10 seconds compilation time is because the code base itself is highly modularized. And we use Bark, and Bark can compile modules separately, and it has very good caching system. So being able to break down the code into different modules, you have to do dependency injection, similar thing on the app level to hook everything up. Cool. Thank you. Yes.
You mentioned lots of code being shared between your projects,
yes.
And I was wondering how actually do you share this code? Is it in a separate repo that is a submodule of your base code, or is it copy and paste, or how is it?
It's a good question. So the long story short is that we share the same repo for any project. So we have a big repo where like all the modules, all the source code are at the same place. So those core components, they are cleaned up and they don't have any external dependencies. Those core like AppKit components, they only have dependencies to other AppKit components. Does that make sense to you? So like any of those libraries, they are very small, they are very lean, and each of those modules is a bulk module, or you can think about it as a Gradle module, like a separated small project. It actually helped us to shape the whole code base better, because now whenever we make a change to those low-level infrastructure stuff, we now think about, okay, does this make sense? Does it make sense to put this feature into this module or not? Does it make sense for every app that's using this module, or it only makes sense for this like one consumer? So yeah, cool. Okay. Yeah.
Just wonder, like maybe two-part question, but like, what's your branching strategy, or if at all any, and the code coverage numbers, and like how do you like maintain like every 4-hour release, like a dog food release, and how do you check on the quality, etc.
Oh, you mean the branching logic for the app? So the question was about like how the branching logic is for the app, and how do we manage the release for the app. So we are pretty aggressive on dog food process. So we cart a new version every 4 hours from our master branch, and we push it to everyone. That's basically it is for dog fooding. And for external testing, for public beta release, because we have a one week release cycle, so we cart a new branch every week on the same day, and then we will have 10 days of soak period. And during that period, we will do beta release every other day. And we will make sure all problems get fixed before we finally push the build to like public 100%. So most of the bugs will be fixed. So if it's like some really stupid bug, it will usually be fixed during the dog food period. And if it's something hard to reproduce, it's some device that our employee don't have, it will go through public beta test, and like we will find it in beta. And yeah, that's basically it is. Yes.
Your deployment automated, deployment to production in beta?
Is our deployment to production automated? A very good question, because we have been working on it recently, just like started a few weeks ago. So I would say it was not fully automated. We have so pushing to employee, like the employee dog fooding is like fully automated, but pushing to production was not automated. But Facebook actually has a really awesome release engineering team where we got a lot of support this year, and we have been trying to automate the last part like recently. Yeah. Cool. Yeah.
Do you measure the performance metrics in a while? For example, the cold start or core performance?
The short answer is yes, but we have been very cautious about it because it uses the user's data. But we do have logging for our core metrics like cold start, scaling performance, especially for network requests, the end-to-end performance time. We are pretty cautious about like using users' data, so we usually design sampling mechanism on the client side to make sure we cover every different category of device, but don't use too much data from a particular user.
Follow-up question: what kind of sample size do you use to share?
So for us, usually I would say like for app has like 500 million users, like usually 1% is pretty big enough. Like it's like it would give you a pretty good resolution on what's going on in production. Hope.
You mentioned release engineering team in Facebook. So like who is responsible for doing the release to the beta release? Is it like the Android dev team, or is there a release team separately? They will just cut out release every like given time.
So it's a collaboration between our technical program manager and our engineers. So we have engineer release captain, which manages the engineering side of a release. So if there is any crash that our program manager doesn't know how to triage, if there's any metric issue in the new release, our engineer, like release captain, will jump on it and try to fix it. But the process, like uploading stuff to Play Store, is taken care of by our technical program manager. So it's separate, like two roles. Yeah. Yeah.
So how do you manage sort of time between refactoring and maybe sort of picking up like technical debt while also continuing to push out features as the team grows up?
Yeah, that's a very, very good question. So it's like it has been like challenging for us since day one, I would say, like because there are so many moving pieces on product layer, and it's constantly changing, and it's pretty hard to do some fundamental change when there are like so many moving pieces moving together. So what we have been doing right now is just like try to be good at planning so that we can pick one or two features to do the conversion or migration first, prove its value, and then start asking product team to adapt to the new pattern. And the key here, I guess, like is that you really want everyone on the team to act like together, so that like we can get everything done within a week or 2 weeks. Because if there is any legacy stuff left behind, it's going to be like technical debt, like for everyone. Yeah.
Yeah. You were talking about employee outputting the application.
Yes.
Are you also doing some integrated automatic integration tests?
The question was about like automated integration tests. Yes, we do automated integration tests, and actually our tests, we don't have a lot of integration test coverage, but we cover the most key flows in our app. For instance, we have integration tests to make sure a new user can always launch the app, a new user can always register and log into the app. It's to cover the basic flow. The way we see it is that like whenever you write a test, it's like buying an insurance for your future. So for this case, like in order to make sure the dogfooding experience is smooth, we like put resources on it and make sure we have tests in place running against every div. Cool. Thanks everyone.